This is RD Sharma solution, class 12, chapter 12, higher order derivatives. MCQ multiple choice questions we are taking. If y is equal to a sin mx plus b cos mx, then d2y by dx2 is equal to. So y is equal to a sin x and then we have b cos. So the angle here is mx. dy by dx we are going to take. See, this y is going to be repeated. So whenever we differentiate, we will try to get this y again. So dy by dx is a. Sin mx is cos mx and differentiation of mx is m. Cos will be minus, so I am writing minus sin mx. Then you have b and then m. Then we have d2y by dx2. This is equal to am. Cos mx will be minus sin mx. Again one more m will come. It will be m square. Then we have bm. Sin mx will be cos mx. Again m will come. So m square will be there. So what we will do here is we will take negative m square outside. That is common. When you take minus m square outside, it will be a sin mx because negative we have taken. So a sin mx plus b cos mx will be inside. So what is this? This is nothing but y. So we have d2y by dx2 is equal to negative m square y. So this is your solution. And there are four options. So what you have to choose is the first one and you have to write like this. Fx is equal to sin inverse x by under root 1 minus x square. So I'll just try to change or suggest a change here in the question being asked because it is f double dash x. It will not be double dash, that is there will not be double or higher order derivative. It will just be one derivative. So 1 minus x square into f dash x minus x fx. Fx is equal to sin inverse x divided by under root 1 minus x square. So when you take this fx, there are two ways you can do. Either you can use the p by q form or the quotient rule, or you can take sin inverse as first and then under root 1 minus x square, 1 by under root 1 minus x square as the second one, or the better way is to multiply both sides by under root 1 minus x square. So you will get under root 1 minus x square into fx is equal to sin inverse x. Now you can apply a product rule here in the form of p dot q. So under root 1 minus x square, differentiation of fx is f dash x, then you have fx, and differentiation of under root 1 minus x square you already know is going to be negative x by under root 1 minus x square, that we have already done in the previous discussions. So d by dx of under root 1 minus x square is this one, negative x by under root 1 minus x square. Alright, and this is equal to 1 by under root 1 minus x square. Why we have done this? Because sin inverse x differentiation is 1 by under root 1 minus x square. Now multiply everything by under root 1 minus x square, you will get 1 minus x square f dash x. You have, when you multiply this, you are going to get x fx. When you cancel this, it is going to be 1. So the question being asked is 1 minus x square into f dash x minus x fx is 1. So the answer here is 1. So the question I have told you what should be the right question. Y is equal to tan inverse of this plus tan inverse of this, then d2y by dx2. So tan inverse a plus tan inverse b formula we are going to employ. So if you know this, you can do it by yourself. There is just simple differentiation which we already know. So there is log e by x square and in denominator you have log e into x square. So log e by x square. Log a by b is what? Log a by b is log a minus log b, and log a into b is log a plus log b. This we already know. So log e by log, so log a by b is log a minus b. So log a b, that is base a, b is equal to y, so y equals y raised to the power a is b only. When both are e, the base is e and there is log base e, it's going to be 1. Alright, so let us differentiate this. So we have log e by 1 by x square, log e by x square. You can directly use log a minus log b here. In the denominator also you have log a into b, that is log e into x square. So when you have log e into x square, it will be log e means log a plus b. So we can just separate them out, log a plus log b. In the first one, log a by b is log a minus b, log a plus b is log a plus log b. So we have here log e, that is log base e. So you can write it as 1, and log x square, so 2 will come in front. You know always log x to the power m is m log x, that is power always come in front. So we have 1 plus 2 log x. In this case, we have already taken this 1 plus 2 log x, and that is going to be in the denominator. In the numerator, it is going to be 1 minus 2 log x. So 1 log a minus log b, as I told you earlier also, log a minus b. So log a e, that is the base is e and it is 1 minus log x squared. So 2 will come in front. Okay, I hope you got the idea. Log, this is the only thing which you need to understand in this. There is one thing which is this one. Second thing is the tan inverse a plus tan inverse b formula. So y is equal to tan inverse. We have here 1 minus 2 log x. Denominator we have 1 plus 2 log x. And tan inverse is there. So tan inverse 3 plus 2 log x. And divided by 1 minus 6 log x. So tan inverse a plus tan inverse b. Tan inverse a plus tan inverse b is equal to tan inverse a plus b divided by 1 minus a into b. What is a here is whatever is inside the first one tan inverse, and b is whatever inside the second tan inverse x. So just assume it to be a. So 1 minus 2 log x divided by 1 plus 2 log x plus 3 plus 2 log x divided by 1 minus 6 log x. So log a plus b. So this is tan inverse a plus b by 1 minus a into b. So we have 1 minus, multiply these two terms, 1 minus a into b. So 1 minus 2 log x by 1 plus 2 log x multiplied by same thing, 3 plus 2 log x divided by 1 minus 6 log x. Now you just have to take the LCM. You have to solve everything here. So I'm taking the numerator right now. Numerator. So just cross multiply, write it with the plus, and then multiply the denominator and write it in the denominator. That is how we do it if we don't know how to take the LCM. So 1 minus 2 log x into 1 minus 6 log x. I'm writing log x in short, plus 1 plus 2 log x into 3 plus 2 log x divided by 1 plus 2 log x into 1 minus 6 log x. This is only the numerator I am doing, remember. So the denominator will get cancelled. You will just see. I am writing the denominator now. Same thing. Multiply these two, put it here. So 1 plus 2 log x into 1 minus 6 log x here. So 1 plus 2 log x into 1 minus 6 log x, and then we have this one 1 minus 2 log x into 3 plus 2 log x. So just cross multiply, write with a negative sign, that is 1 minus 2 log x into 3 plus 2 log x. In the denominator you have 1 plus 2 log x into 1 minus 6 log x, and you multiply it by 1. Write it here. So this is 1 plus 2 log x. I'm just writing log x as L. Now denominator, you can cancel these two out. Now you have to multiply everything. I hope you'll be able to do. We are short of space. So just multiply everything. 1 minus 2 log x into 1 minus 6 log x. I'll show you one of it. These all have to be multiplied. So let us see what do we get. 1 minus 2 log x into 1 minus 6 log x. What do we get? So when we multiply this 1 minus 2 log x, it will be 1 minus 6 log x minus 2 log x plus 12 log x. So log x square will be there. So essentially you will get 1 minus 8 log x plus 12 log square x. So from here to here, this is the first one. Second you multiply, you will get this one. And this one you have to multiply the same thing which I just showed you. You will get this is in the denominator. Then you have 1 minus 2 log x into 3 plus 2 log x. When you multiply this, you will get. And these are quite easy. I mean, when you will see, there will be a cancellation in numerator. In denominator, there are only certain terms that will be left. So 12 plus 4 is 16. This minus 8 log x plus 8 log x gets cancelled. You have 4 plus 16 into log x whole square. Denominator also, you have this 4 log x and 4 log x gets cancelled. 4 minus 12 is minus 8. So minus 8 log x whole square. 1 minus 3 is negative 2. So numerator I am taking 4 common. Denominator, you have to take negative 2 outside. So 1 plus 4 log x whole square, 1 plus 4 log x you will get in the numerator and denominator. You can just cancel them out. So when you cancel them out, you will get 4 by minus 2, that is minus 2. So tan inverse minus 2 will be there. So y is equal to tan inverse minus 2. Okay. Now since you have to find out dy by dx, we have just solved the expression. We have not differentiated as of now. So when you differentiate it, you'll see that tan inverse minus 2 is a constant. It will be a 0. When you double differentiate it, it will again be 0. So the answer will be 0. After all these effort, dy by dx is going to be 0. Let fx be a polynomial, then the second order derivative of f e to the power x. So double differentiation you have to do. So f e x, f, so y is f e to the power x. So dy by dx is f dash e to the power x, and differentiation of e to the power x will be e to the power x. Now d2y by dx2 is going to be f dash ex, e to the power x will be e to the power x, plus e to the power x, f dash e to the power x will be f double dash e to the power x. Alright, but you will not stop here. You have to do inside that e to the power x is there, so you have to differentiate that also. So when you do this, you see that this is going to be the final solution, and e to the power, this is the first term, and e to the power x and e to the power x, when you add the power, it will be e to the power 2x. So f double dash e to the power x, e to the power 2x will be the second term. First term you already know, it is e to the power x, f dash e to the power x. Now y is a cos log x plus b sin log x, you have to find out, or then x square y2 plus xy1. So y2 is d2y by dx2, y1 is dy by dx. So we have to do the both of these, but this y is going to come again back. So there is no trick here, just this a cos log x and b sin log x will come up somewhere, and what you have differentiated, that may also come up, the first differentiation that may come up. So y is equal to a cos log x, and then we have b sin log x. So y1, that is dy by dx. So minus a cos log x is minus sin log x is 1 by x, plus b sin log x is cos log x, differentiation of log x will be 1 by x. Now what you can do here is, you can differentiate it separately, or you can differentiate them together also. It's up to you. So you can combine this x and then differentiate. So let us do this. In the p by q form also you can do this. So y1 is this. See, there are different terms and there are different ways to do the same thing, as I have been telling in the previous discussion also. y2, that is the double differentiation where we are doing this, minus a is constant, sin log x by x. So I'll do it separately and then we'll combine it. So we have sin log x divided by x. The differentiation, the denominator will be x square. P by q form we are following. We have x square. We have x sin log x minus sin log x. See, this sin log x differentiation will be cos log x, and log x differentiation will be 1 by x, minus sin log x was already done. Differentiation of x will be 1 only. So we have cos log x minus sin log x divided by x square. This is the first differentiation, that is the differentiation of sin log x divided by x. B plus b. Now cos log x divided by x, I'll do it here. Again, x square in the denominator, x I'm writing like this. Cos log x is minus sin log x. Differentiation of log x will be 1 by x. Then we have minus cos log x is already done. Differentiation of x is going to be 1. So inside this, you are going to get, I'm taking negative common from both these terms, which we have just done. So x square in the denominator, you have sin log x plus cos log x. You can write like this. So we will combine these terms, and we'll try to find out why we have x square in the denominator. You can just get rid of this x square and take it into the left side, x square into y2 minus a cos log x. So I'm multiplying it first with minus. So minus minus will be plus. I'll just change the sign. So minus minus will be plus. And here both will be negative because negative is outside. So I'm just opening it up now. Minus b sin log x minus b cos log x. Okay. Now a cos log x plus b sin log x is what? A cos log x we already have, and b sin log x. So these two terms you can take negative outside. A cos log x plus b sin log x is y. You can replace it by y. Then we have a sin log x minus b cos log x. But you have already done y1 differentiation of first degree. You have already completed. Remember? So when you differentiate it, it will be minus a sin log x. Remember, plus b cos log x. So if you take a negative outside, okay, and you already have this minus y term already was there. So I am taking these two, I am taking negative outside. So inside this you will get minus a sin log x. Here you have plus b cos log x. And this is nothing but y1. This is the first differentiation. This is x into y1. So minus y minus x into y1 is equal to, on the left hand side we already have x square y2. So x square y2, and you take this x y1 on the left hand side, only negative y will remain on the right hand side. So x square y2 plus x y1 is equal to negative y. This is minus y. Answer is negative y. Now x is 280, y is equal to 80 square. d2y by dx2 at x equals to half you have to find out. X is 280, y is 80 square, dx by dt is 2a, dy by dt is 280, dy by dx is dy by dt divided by dx by dt. So 280 divided by 2a, you can cancel 2a, t will come. d2y by dxt is dt by dx, because t differentiates, t is only remaining. dt by dx is reciprocal of 2a, 1 by 2a. At x equals to half, there is no x, so it will be half only. So this is the logic which I told you, and this is how you are going to do it. This is for reference because this is how you are going to write it. Now x is ft, y is equal to gt, d2y by dx2 you have to compute, d2y by dx2. So this 12.2 exercise we have already done, but for the sake of completion we'll do it. X is equal to ft, y is equal to gt. So dx by dt is equal to f dash t, dy by dt is equal to g dash t, dy by dx is dy by dt divided by dx by dt. So that's going to be g dash t divided by f dash t. d2y by dx2. Now you have some p by q form on the right hand side. So it's going to be f dash t whole square. I'm applying the p by q quotient rule. F dash t, g dash t is g double dash t minus g dash t. Now ft will be f dash t, f double dash t. Will not stop here because we are differentiating with respect to x, but only t is there on the right hand side. So dt by dx will also come. dx by dt is f dash t, so you can take the reciprocal and write it as 1 by f dash t. F dash t we already have square, so it will be f dash t whole cube in the denominator. So you just find out whichever is suiting your answer and just check it, because there are 4 options. That is the solution. Y is equal to sine m sine inverse x. Then 1 minus x square y2 minus xy1 is equal to. So this in previous exercises we have already completed this. For the sake of a completion, we'll attempt this. Y is sine m sine inverse x. So let us differentiate. dy by dx is sine is cos only. We'll call it as y1. Sine is cos m sine inverse x. Now differentiate m sine inverse x. So m is a constant. You can just write m. Sine inverse x is 1 by under root 1 minus x square. Alright. Now y2 differentiation will be done. That is first differentiation we have already completed. y2 differentiation, that is d2y by dx2 we have to do. So you can use the p by q form, you can use the p into q form, that is p can be cos m sine inverse, q can be 1 by under root 1 minus x square, that's up to you. So you can apply whichever approach you want. The result is going to be same. So what should we do? We can use the, and this constant we are going to take in later part. So under root 1 minus x square, I am applying the p by q quotient rule. Cos m sine inverse x is minus sine m sine inverse x, and differentiation of m sine inverse x is m 1 by under root 1 minus x square. There is a negative also that I'll just come up to. I have just missed a negative here. And this will be cos m sine inverse x, and differentiation of under root 1 minus x square, that will be done. So we've just seen a question. It will be negative x by under root 1 minus x square. So negative becomes positive. Positive x by under root 1 minus x square. Under root 1 minus x square whole square. So this root you can cancel. Root you can cancel. So multiply everything with m, because m was outside already. So the first term is going to be m square. Now this under root 1 minus x square, under root 1 minus x square, you can just bring it down or you can just cancel these two. Whichever way it suits you. So you'll just see that, because ultimately this under root 1 minus x square in the denominator is 1 minus x square, and that 1 minus x square has to go on the left, because we have y2 into 1 minus x square in the question. So under root 1 minus x square has to go here. So I'm just taking this m square, the first term I'm taking. So we have m square under root 1 minus x square under root 1 minus x square, because it was under root 1 minus x square whole square only. So m square, so we don't have m here, so we cannot take this. I'm just trying different stuff, okay? So we have this m into, let us have whatever is inside. M sine inverse x under root 1 minus x square plus x cos m sine inverse x. This is the inside term. Now this under root 1 minus x square under root 1 minus x square in the denominator, because this was under root 1 minus x square whole square. So I'm writing under root 1 minus x square whole square as under root 1 minus x square into under root 1 minus x square. These two under root will give you 1 minus x square. So y2, I'm taking this 1 minus x square on the left hand side. So y2 into 1 minus x square. Okay. So this has gone on the left. Only right hand side is left. So you have m sine inverse. Now I'm multiplying it. So m will be m square. So m square m minus sine m sine inverse x divided by 1 minus x square, because as I told you, this under root 1 minus x square we have already taken outside. Now we have this mx cos m sine inverse x. So you have to have this one in the denominator, because 1 under root 1 minus x square is still left with us. It got cancelled with the first term, but it has to come with the second term. But what is this? This is y1. This whole term, if I just forget x, other term, whatever we had is y1 only. So you can write it as plus x y1. Now y was already sine m sine inverse x. So this term is y only. You have a m square y, but I told you that I missed the negative. So I have to, because first thing was cos m sine inverse x differentiation. It was negative sine m sine inverse x, remember? So this, the negative I missed, I'm going to put it here, because cos theta differentiation is minus sine theta. So I'm now allowing it here, 1 minus x square into y2 minus ym square plus x y1. So just take this according to the question, just change the positions. 1 minus x square into y2 minus x y1 is equal to negative m square y. So this whole term, this question is asking what is on the right. It's going to be minus m square y. So your answer is this one, minus m square y. So as I told you, I took a different approach. You can take a different approach. It's up to you, whichever you want. I hope you got the idea. So this is how we complete this. This will take in the next discussion. Till then, thank you so much. Take care of yourself.